Consider an inclined plane having an angle theta on which a body of mass m has been placed, and the body is pushed up the inclined plane at a certain velocity v naught. Now, suppose if the coefficient of friction on over this inclined surface is say mu. Now, what is the acceleration of this block as it travels up the inclined surface, and what is the acceleration of this block as it travels down the inclined surface? So as it moves up, if you draw the free body diagram of this block, there are a few forces acting on it. One is vertically downwards mg, and there is a reaction force N which is perpendicular to this, and there is a friction force acting like this. If you're calling it as F, friction force, if the block is moving in this direction, it is pushed upwards on the inclined plane, then the friction force will act opposite to the direction of the motion. So these will be all the forces N, F and mg. So along this direction, right opposite to the normal force, there is a component of mg which is mg cos theta, and parallel to the inclined surface there is a component of mg which is mg sin theta. Now since in this direction there is no motion, we can say that N is equal to mg cos theta. Also, as it moves upwards, the total force acting on this block downwards will be equal to FD. If you call the total force acting on the block as it moves upwards, or the total force acting downwards, will be equal to mg sin theta plus friction force, which is mu n. So mu n is equal to mg cos theta. So the total acceleration downward when the block is moving upwards is equal to this divided by m, which is equal to g sin theta plus u g cos theta. Similarly, when the block is moving downwards, everything will remain the same. The difference will be that the friction will be acting upwards because the motion of the block will be down the slope. So in this case, the force will be equal to mg sin theta minus mu mg cos theta, and acceleration will be equal to this force divided by m, g sin theta minus mu g cos theta.